Hello everyone, very good evening and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. This is Sanjay Rathi and guys, now it is part 2 of what network theory, IISC Bangalore previous year question series. Why? Because this time the GATE 2024 is conducted by IISC Bangalore, okay, and 2002, 2008 and in 2016 again the paper was conducted by IISC Bangalore. So we are going to discuss the questions from what network theory so that you will get the idea about the pattern, type of the questions, and definitely it will boost your confidence. But let me know that sound quality, picture quality, everything is fine guys. Yes please. Okay, I think now everything is fine. So guys, we will solve questions from 2002, 2008 and 2016. So in the part 1 we have solved number of questions from what electronics branch, right? Questions from basics of the network, then what theorems, transient, two-port network, right, and what graph theory, all the topics. No doubt that is not mentioned in the syllabus, but yes, in previous year we have some questions on network function also, so we will solve the questions. So I think that is everything is fine. So please share the link of this session, subscribe our channel, right now, and finally like the session. Okay guys, this is a part 2. Then this is my introduction. Myself Sanjay Rathi. I am having 22 years of teaching experience and I have trained more than 1 lakh students for these competitive exams, and I have qualified and selected for engineering services exam that is conducted by UPSC. तो बहुत ही important role है for previous year question paper. To watch the previous year question paper, solve questions from that, and it will boost your confidence guys. Whether it is ISRO, whether it is GATE exam or what engineering services exam. What about the technical syllabus? It is almost same. In some papers we have some extra subject, but at the core the syllabus of GATE examination. Okay, तो चलिए कुछ solve करते हैं questions. Now these are my ranks: AIR 16 in ESE 2005 and AIR 21 in ESE 2008. Okay, then this is my Telegram channel. Already I have uploaded the PDF of previous class, and just within 2 minutes I will share the password for that PDF. So stay tuned with me so that you will get the password and watch that session. That is the part 1, and you can download the PDF also. Okay, and where I have given the solution for all the questions from 2002, 2008 and 2016. And if you want daily important questions for latest information about the exams, for notification of the class, right, and if you want to clear some doubts, then you can join my Telegram channel, that is Electronics by Sanjay Rathi. Okay then. If you have cleared the engineering services mains, then share your result and get free mock interview with our expert panel. Remember, in interview we can get number in the range from 60 to what 160 marks, right? So if try to give the mock test as much as possible. I am talking about the mock interview. Okay, तो आप boost कर सकते हो अपने marks को 60 से कहां ले जा सकते हो up to what 160 marks. तो आपका selection sure हो जाएगा, तो आप कर सकते हैं, right? Okay, instrumentation engineering according to update syllabus by HPCL last year. Thank you, but currently exam is on 3rd of September. Okay, लक्ष्मी प्रसाद, आपके कमेंट्स पर हम लोग काम करते हैं, right? Then definitely we will inform you about that. Then guys, last time we have solved one question. I have given some homework. Then tell me what is the answer for this question. I have given, just find the answer. I have given you the trick. So quickly, without any delay, we will solve number of questions on what network. So this is a part 2. Then 1 minute. Okay then. In the figure shown the current IES, that is in 2016, that was the paper conducted by IISC Bangalore, and this is a 2-mark question in 2016. Again, this is a very simple question, but what is the answer for this one? So last time I have given you the homework for this particular question. Tell me what is the answer. Now simply this is connected, like this is 0, So what is the voltage here? 0. What is the voltage here? 0. What will be the voltage here? 8 volt. Now you have to find the I. Then at this node, what is the current in this branch? What is the current in this branch, and what is this is the I we can find. But to find the current in this branch, and to find the current in this branch, we have to find the voltage at this point. Let this voltage is V1. So you can write the KCL at this point because you have to find I. So what is the KCL? V1 minus 0, that is V1 by 1, plus V1 minus 8 by 1, plus V1 minus 0 by 1, plus V1 minus 8. We can interchange the 8 and 1 ohm. So it will become V1 minus 8 divided by 1 is equal to 0. 1, 1, 1 lost. This is the 4V1 is equal to 16. 4V1 is equal to 16. So what is the V1 is equal to 4 volt. Yes. Now, if you have the value of the V1, then you can find the current. Watch this. Because it is a higher voltage, it is a lower voltage. So there will be the current in this direction. 8 minus 4 upon 1. What is the current here? 4 ampere. 8 minus 4, because V1 is 4, so 8 minus 4 upon 1, that is the 4 ampere. What is the current here? 1 ampere. So definitely, what is the distribution of the current? 4 here, 1 here. So what is, this is the outgoing, this is the outgoing. So what is the incoming current? 5 ampere. So I have applied the KCL at this point. Incoming 5, outgoing 4, outgoing 1. Now 5 ampere. In this branch, this is the 5 ampere. Now this is 4 volt. So what is the incoming in this branch? 4 minus 0 by 1, that is the 4 ampere. Now you can apply the KCL at this point. So what is the KCL? What is the incoming current? 4 is equal to what are the outgoing current? 5 plus I. What is the I is equal to 4 minus 5, that is the minus 1. That is minus 1. Answer for this question is what? Minus 1. So I have given you the homework. Try to solve this type of questions. So this is a minus 1 is the answer for this one. Okay. Now this is a 2-mark question. Next question. Now this is a question from the transient, guys. Assume that the circuit in the figure has reached the steady state before time t equal to 0. When the 3 ohm resistor suddenly burns out, this resistor is suddenly burns out, means it is actually resulting in an open circuit. It is written in the question. The current IT at t equal to 0 plus is, what is the current IT? What is the current through this? IT at t equal to 0 plus you have to find. Now, it is a question on transient. It is a question on what? Initial condition. Now, it is burned out means it will act as open circuit, right? Steady state before time t equal to 0. Under steady state, both the capacitor will act as what? Open circuit. So how we can solve this question now? And you have to find the current. Then remember, yes. Now this is the capacitor. This capacitor will act as open circuit, 3 farad. This capacitor will also act as open circuit. Now what is the resistor here? 2 ohm. What is the resistor here? 3 ohm. And that is 2 ohm resistor is connected here. And what is the 1 ohm and 12 volt battery here? This is 1 ohm. Now this 2 and 3 are in series. Watch this diagram carefully. This capacitor acts as open circuit, this capacitor acts as open circuit. And what about this 2 ohm? There is no current through 2 ohm resistor. And this is the diagram exactly at 0 negative. 0 negative means both the capacitors are charged and circuit is in under steady state. Steady state at t equal to 0 negative. Therefore, capacitor act as what? Open circuit because it is DC. So all the capacitor will act as open circuit. Now, according to voltage division rule, because there is no drop across the 2 ohm, so what is the voltage at this point, from this point to this point? You can find the voltage. So what is the voltage here? 2 and 3, that is the 1. You can find the Vx from this point to this point. So what is the Vx? This is nothing but voltage across this. So Vx is equal to 5 divided by 1 plus 5 into 12. And that is 10 volt. That is what? 10 volt, right? Now, once you have the idea about that, 10 volt, then what is the voltage across this capacitor? What is the value? 3 farad. Like this is the VC1. And what is the initial value of the VC2? So you can apply the voltage division rule. So according to voltage division rule, VC1, it is inversely proportional to capacitor, value of the capacitance. So what is the VC1? 10 volt divided by C1 plus C2, 3 plus 2. If you want to find the voltage across this, it should be multiplied with the 2. Then that is the 4 volt. And what is the VC2? VC2 total voltage is 10 volt. So this is the Vx minus VC1. 10 minus 4, that is what? 6 volt. So voltage across this capacitor is 6 volt. Voltage across this capacitor is 4 volt. Total 10 volt from this point to this point. Under steady state, exactly at t equal to 0 plus. Now, exactly at 0 minus as well as 0 plus, because capacitor does not allow sudden change of voltage. Now what will happen? Exactly at t equal to 0 plus, this resistor is burned out. So please remove that resistor. So when we are removing this resistor, now remove this resistor. This will act as open circuit. Now this is the diagram exactly at t equal to 0 plus. Now capacitor allows what? Sudden change of current. Does not allow sudden change of voltage, but it will allow sudden change of current. From this point to this point, what is the voltage? 10 volt. What is the voltage? 12. 12 minus 10, 2. 12 minus 10 is equal to 2. 2 divided by 1, 2 ampere current here. 2 ampere current in this point, guys. Now, watch this. This is a 4 volt, right? Remember, this is a 4 volt and this is what? This is open circuit. This is open circuit. Now, same you can find the current here. Total 2 ampere. This is the 4 volt across because these two are connected in parallel. So 4 by 4. What is the current in this branch? From this point to this point. This is the 4. So 4 by 4, 1 ampere. 1 ampere will rotate because it is open circuit. And then, what is this current? 2 minus 1. That is the 1 ampere. Again 1 plus 1. What is the current through this capacitor? 2 ampere. And finally, what is the current here? 2 ampere. So that is the path of the current from this point. One path is this one and one path is directly. And we are getting the, what is the current through this branch? What is the current IT? Minus 1 ampere. Because we are getting the current in this direction. That's why answer is what? Minus 1 ampere. Okay. I think now it is clear. This is the second question. Then, so you are getting, Lakshmi, everything right? How to write the answer in exam. This is the method. So that is the question. Now, next one. Tell me what is the answer for this question. Next question. That is the two-port network. Two-port network. Please read question carefully, everyone. First of all, read question carefully and give me the answer. What is the answer for this one? Yes, please. Now, so you have read the question? Read the question, this one? Linked question means it is of 4 marks, guys. It is of what? 4 marks. Quickly we will solve. Then a two-port network shown below is excited by external DC. This is the external DC 6 volt. This is the V1. That is the V2. This is the ammeter. It will read the value of the current. Always remember, for ideal voltmeter, the resistance is what? Infinite. And for ideal ammeter, internal resistance is what? 0. So what will be the current across this? 0. And what is the drop across this ammeter? 0 if it is ideal. So what is written? Voltmeter, this one all assumed to be ideal as indicated. Under following switch condition, the reading obtained are S1 open, S2 closed. That is the A1, V1, V2, A2. S1 closed, S2 open. S1 closed, S2 open, then that is the condition. Now, these conditions are given, and what is asked here? Then this is the condition, and what is asked here? First of all, read the question. Z parameter matrix for this network. What is the Z parameter? This is a very, very simple question. I am going to give you the answer about that. What is the Z parameters? In first diagram, watch this. Okay. Because S1 is open. So what is the Z parameter? You can write V1 is equal to Z11 I1 plus Z12 I2. And V2 is equal to Z21 I1 plus Z22 I2. So when we are saying S1 is open, S1 open means I1 is equal to 0. When I1 is 0, you can find Z12 and Z22. So what is the Z12? Z12 is equal to V1 upon I2. V1 upon I2 with I1 0. So I1 is already 0. What is the V1? 4.5. And what is the I2? I2 is equal to reading of the A2. Reading of the A2 is 1 ampere, and that's why the answer is 4.5. This is the value of the Z12. Now, you can find the Z22. Z22 is equal to V2 upon I2. So what is the value of the V2 here? 1.5 upon 1, that is nothing but 1.5. This is the 1.5 ohm, 4.5 ohm. This is the value of Z12 and Z22. Now, from the second condition, S1 is closed, S2 is open. Now it is closed, it is open. So therefore the I2 is 0. Now what is the reading? So from that you can find Z21 and Z11. So what is the Z11? V1 by I1 with I2 0. Because this is open, that's why I2 is 0. Now V1, what is the value of V1? 6 upon. What is the value of I1? Right, 4. 6 upon 4, 1.5. What is the Z21? Z21 is V2 upon I1 with I2 0. Then V2, what is the V2? 6 upon I1, 4. V2 is also 6 upon 4, that is again 1.5. Now you have all the 4 parameters, 1.5, 1.5, 4.5 and 1.5 here. Watch this. 1.5. So which answer is correct? This one. Z11, Z12, Z21 and Z22. So according to the given condition, you can find the values here. Okay. This is a very, very simple one. Now, what is the linked question here? So this is in GATE 2008. That is the by IISc Bangalore. Ab bataiye, what about the level? Out of 5 star, how much star you will give? This question. Out of 5 star, how many stars? Simple 2-port network. But statement is given, you have to use the definition of the 2-port network. Okay. Then second one. Second question is Z parameter matrix for already we have find, answer is C. Then H parameter. What is the H parameter for this network? If you want H parameter, remember V1 is equal to H11 I1 plus H12 V2. This is V2. And second one is, this is the V1, H11 I1 plus H12 V2, and second is I2, H21 I1 plus H22 V2. Guys, H12 and H22 you can find by making the I1 is equal to 0. Already there was a condition by making the I1 is equal to 0. You can find the V1 by V2, you can find the I2 by V2. So from the I1 0 means which condition? That is the condition. This is the condition. 1 minute. When the I1 was 0, this is the condition. Yes, please. Now watch this. You can find V1 is equal to H11 I1 plus H12 V2. So what is the H12? V1 by V2 with I1 is equal to 0. Here it is the I1 is equal to 0. So what is the V1 and V2? It is given 4.5, 1.5. 4.5 divided by 1.5, that is nothing but 3. 4.5 divided by 1.5, that is what? 3 is the value. Similarly, you can find H21. What is the H21? I2 by I1, H22, I2 by V2 with I1 0. Then you can find H22, I2 by V2 with I1 is equal to 0. What is the I2 here? 1 ampere. What is the V2 here? 1.5. 1 divided by 1.5 with I1 is equal to 0. Now first of all check the answer. Check the answer. What is the H12 and H22? 3 and 1 divided by 1.5. First of all watch the answer. Then this is the H parameter. This is 3 divided by 1.5, 0.67. Here we are getting in these two options. A may be correct, C may be correct. Now you have to find the H11. What is the H11? H11 is V1 upon I1 with V2 is equal to 0. Now guys, to solve this question, we have the Z parameter because it is a linked question. What are the Z parameters? 4.5 I1 plus 1.5 I2 plus, this was the answer for Z parameter. 1.5, 4.5, 1.5, 1.5. Sorry for that. This is the 1.5. 1.5, 4.5, 1.5, 1.5 I2. Now by using this equation, what is the H11? V1 by I1 with V2 is equal to 0. You have to make the V2 is equal to 0 guys. When I am making the V2 is equal to 0, you will get 1.5 I1 plus 1.5 I2. So what is the relation between I1 and I2? Because you want to find the H1 by I1, so what is the I2? I2 is equal to minus of I1. Put this value in this equation. So 1.5 I1 minus 4.5 I1. So it will become V1 is equal to 1.5 I1 minus 4.5 I1. What is the V1 by I1? That is nothing but H11 is equal to minus 3. H11 is what? Minus 3. So this only this option will satisfy. So we have find this, we have find this, we have find this. So no need to find this. Otherwise you can find the H21. H21. What is the H21? I2 by I1. Already we have find. What is the I2 by I1? Minus 1. I2 by I1 is equal to minus 1. This is the minus 1 correct one. So this is again a very easy question. So this is from the two-port network. Next one. Next question. Alright, please give me answer in comments box. Right. That session will boost your confidence guys. Okay, wow, IISC Bangalore, which type of paper? Right. So that is a two-port network. Very easy question. 1 mark question. In 2016 last time. Consider a two-port network with transmission matrix ABCD if the network is reciprocal then. So what is the condition for reciprocal for ABCD parameter? Very easy. Determinant AD minus BC is equal to what? 1. So determinant is equal to 1, then the network is called reciprocal. Means theoretical question. Theory means what about the condition for the symmetrical network and reciprocal network. To get the idea about that. So this is the AD minus BC is equal to 1. Okay. Okay then. The next one. The Z parameter matrix for the two-port network shown is Z parameter. Z parameter ZA, ZB, ZC, it is given, it is ZC. And shown here, it is 2Z, J omega, J omega, J omega 3 plus 2J omega. Where the entries are in ohms. Suppose ZB is equal to RB plus J omega. Then the value of RB is equal to. What is the value of the RB? That is you have to find. RB. Right. And that is given 2J omega, J omega. So again, this is a very easy one. What are the Z parameters for T network? ZA plus ZC. ZC. This is the Z21 and ZB plus ZC. These are the 4 Z parameters, Z11, Z12, Z21, Z22. Okay, what is given here? Suppose the ZB is equal to RB plus J omega. Okay, now this is given. So you can say what is the ZC is equal to J omega. From this you can compare ZC is equal to J omega. And what is the ZB is given RB plus J omega. Okay, remember. And ZB plus ZC, what is the ZB plus ZC? Compare this. 3 plus 2J omega. So what is the ZB? This is J omega. ZB is equal to 3 plus 2J omega minus ZC. ZC is J omega. It will become 3 plus J omega because ZC is J omega. Now this is ZB. Now you can compare 3 plus J omega with this RB plus J omega. So what is the value of the RB? 3 ohm. Value of RB is nothing but 3 ohm. So again it is a 1 mark question. 1 mark question. You can directly put here values. Right, this is the 2J omega. This is the J omega, means this is the J omega. Directly on the diagram. This is the J omega, J omega. This is the 2J omega. This is nothing but ZA plus ZB. ZA plus ZC. So this will become J omega. Right. This is the 3 plus 2J omega. That is the ZB plus what? ZC. So it is a 3 plus J omega. That is what? Directly. So directly you can compare and you can say RB is equal to what? 3. No need to write all the equations. In exam we have to save our time also. Okay. This is a very easy one. 3 plus J omega, and that is well 3. Next question. Next one. The Z parameter matrix for the 2-port network shown is in 2016 lattice network. Right, it is not a symmetrical lattice. ZB is 0. This is called ZA. This is called ZD. One is called ZB, one is called ZC. But ZB and ZC are 0. These are called parallel arm. These are called series arm. And that is the network. Z parameter matrix for the 2-port network is shown in the figure. What is the value? What is the value? You have to. 2 mark question in 2016. Again from 2-port network. Now, watch this diagram carefully. How we can find the Z parameter? Remember, first of all, watch this diagram. Then this is a LUT, or you can say this is 1 dash. This is a port 1, port 2. That is the output port. Now we are giving the input, that is what? V1. Here what is the current I1? What is the voltage V1? Here voltage V2, and let this current is I2. Now you can redraw the diagram. So what is this? This is like 1 dash. Here you are having the 2, here you are having the 2 dash. Between 1 and 2 there is a resistor 3 ohm. Between 2 and 1 dash there is no resistance, short circuit. This is 2 and 1 dash. Similarly between 1 and 2 dash, short circuit. 1 and 2 dash, short circuit. And between 2 dash and 1 dash, 6 ohm. 6 ohm. And that is the case. This is the V2 and this is the I2. And this is the I1 and that is the V1. Okay, now Z parameter Z11. What is the Z11? V1 by I1 with I2 is equal to 0. Where simply 6 and 3 are in parallel because I2 is 0. So V1 by I1 is nothing but 6 parallel with 3. 2 ohm. 2 ohm. Okay. Second, with the I2 is equal to 0, you can find the Z21. Z21. What is the Z21? V2 by I1. V2 by I1. Now watch this diagram. What is the V2 here? Watch this. This is the ground. So let this is the Vx. This is the Vy. So V2 is Vx minus Vy. V2 is equal to Vx minus Vy. So what is the Vx? It is connected to ground, that's why 0. And now what is the V2? V2 is, because it is connected to ground, V2 is nothing but V1. Why? Because this is parallel. So from this point to this point, short circuit. So what is the Vy? Vy is nothing but V1. It is 0 minus V1 is equal to 0. So that is nothing but minus V1. So what is the V2 by V1? That is nothing but minus V1 by I1. And what is the V1 by I1? 2. V1 by I1 is 2, so it will become minus 2. It will become minus 2. In this way, you will get the diagram. 2 and minus 2, but it is a purely resistive network. Symmetrical network from both the sides. From this point. So you can find the values. By similar way, you can find, but in one option only, in one option we have the 2 minus 2. This is minus 2 and that is what? 2. Answer is what? A. Answer for this question is what? A. You can again redraw the diagram, same thing. I am just giving you the hint. Redraw the diagram for the next one. You can take here. Let this is the 2, this is the 2 dash 1. So between 2 and 1, 3 ohm is connected. And that is short circuit. This is 1 dash. 2 and 1 dash, short circuit. This is 3, that is the 6 ohm. You will get the same diagram. Yes? So here, the 2 or 1, this is the 3 ohm. Then this is what? This is I1, this is V1. This is V2, this is I2. Again, you will get the two values Z22, V2 by I2. That is equal to 2. And Z21, right? This one. Z12 minus 2. Same answer. Okay. Redraw the diagram and you will get the answer for this question. 2 minus 2 minus 2 and 2. Then next question. So देखिए on 2-port network, easy questions. And then guys, network function. Network function, the driving point impedance of the following network is given by. Driving point. Normally we are having the network function to get the definition of what driving point impedance, transfer function and so on. So what is the driving point impedance of the following network is given by. So guys, try to solve all these questions and join my Telegram channel, that is Electronics by Sanjay Rathi, where I will upload the PDF of this session. Okay. And like the session. So driving point impedance of the following network is given by. The component values are, these are the 3 connected in series. Now, to watch this, this is simply very easy. In parallel case, you can find what? Admittance. Admittance means Y is equal to 1 by Z. What is the admittance? Because of the resistor 1 by R. This is called conductance G. This is G. Plus, what is the admittance? Because of the capacitor J omega C. And what is the admittance? Because of the inductor? Minus J by omega L. Minus J by omega L, or this is the SC or minus that value. Okay. Now, what is Z is given here. Here 0.2s upon s square plus 0.1s plus 2, that is Zs is given. So what is the reciprocal of this? You can find a reciprocal of this. .2s upon s square plus 0.1s plus 2. Now, what is the ys? S square plus 0.1s plus 2, and that will become divided by 0.2. It will become 5s, because 10 by 2, that is the 5, plus 0.5 ss cancel, plus 20 divided by 2, that is the 10 by s. 10 by s. Or You can write what is the admittance because of this SC. What is the admittance because of that is 1 by R, and that is this 1 by SL. 1 by SL. So what is the Y again? You can write in terms of SL. So this is what SC plus 1 by R plus 1 by SL. Now compare this with that. You will find that C is equal to, compare with this, C is equal to 5 farad. Then what is the R is equal to, this is the 1 by R is equal to 0.5. So what is the R is equal to 2 ohm. And inductance L, 1 by L is equal to 10. So what is the L is equal to 1 by 10, that is nothing but 0.1. Value of the inductor is 0.1 Henry, capacitance 5 farad, and resistor 2 ohm. Very, very simple. Directly network function, question on network function. Driving point impedance means directly you have to find, you can change the value Y here and then you can compare. This one is. Answer is D for this particular question. So देखिए, some students watching the syllabus, sir, in a syllabus network function is given, graph theory is given. So we will solve some questions on graph theory. Watch that. On basics of this topic, filters, high pass filter, low pass filter, band pass filter, band reject filter. Very simple question on this topic, guys. Okay. Now, so this is the question on network function. Now, guys, you can join our BYJU'S exam prep courses, and for more detail, first of all, download the BYJU'S exam prep app from Google Play Store. If you have already downloaded, then go through the lectures available on that, and you can also join the courses for 3 days free of cost. Okay, just for demo classes you can join. For more detail, you can call the number and first of all join this app. Okay, and go through it. Then now I am going to start with what? Electrical engineering. Already I have given the solution of electronics. Guys, already we have done with electronics 2002, 2008, 2016. How many students want the PDF for this session? PDF. So already I have shared the PDF on my Telegram channel, that is Electronics by Sanjay Rathi. Okay, and then the password is for that PDF is 2002, 2008, 2016 IISC. That is it. These all are in capital. IISC it is in capital, and that is the password. You can open that PDF. Now the password for this PDF at the last I will share with you, and the PDF will be available on my Telegram channel, that is Electronics by Sanjay Rathi. Okay, this is the password. Now the next one from electrical, that is the first question in 2008 electrical, 2 marks from IISC Bangalore. Assuming ideal elements in the circuit shown below, the voltage VAB. Everyone try to solve this question. Okay, what is the 2 marks question? Only we have to find the VAB, and this is the open circuit. Only we have to find the voltage. What is the ampere? 1 ampere. So 1 ampere current will pass through this. What is the 1 ampere? There is a drop. 1 into 2. What is the drop? 2 volt. Now you can apply the KCL, proper KVL, sorry. So what is the VAB? Minus VAB, because it is minus, plus minus VAB plus 2 minus 5 is equal to 0. So what is the VAB is equal to 2 minus 5, that is minus 3. Simple. Within 1 minute you can solve. Within 30 seconds you can solve. Minus 3 is the answer for this one. Minus 3 is the answer for this question. Simple KVL, and this is the current source passed through this. Okay, so that is the case. Now, second one. In the circuit shown in the figure, the value of the current I will be given by. What is the value of the I? Again, very, very basic questions. And remember, it is a balanced question in 2008. Electrical engineering 2 marks question again. First question from electrical, second question from again electrical engineering. Now, what is the value of I? It is given. To find the value of I, we have to find the value of VAB. What is the VAB? Watch this. This voltage is VA, this voltage is VB. What is the VAB? Once you have the value of the VAB, then you can find the value of the current here. Then watch this diagram. What is the value of VA here? VAB is nothing but VA minus VB. VA means voltage division rule. 1 upon 1 plus 1. 1 upon 1 plus 1 into 5. 2.5 volt. Then this is the VB. What is the VB? You can write. Watch this. You can find the value of VB in terms of I. So what is the VB? This current enter. This is lead. This is the reference. I into 1. That is the value of VB. I into 1. That is nothing but I. Now what is the VAB? 2.5 minus I. 2.5 minus I. This is the 2.5 minus I. Now, if this is I, now you can write a KVL in this loop. Write down the KVL. Minus 4 VAB. This is minus 4 VAB plus 3I plus 1I is equal to 0. This is plus minus, this is plus minus, plus 3I, it is equal to 0. What is the VAB? 2.5 into I. 2.5 minus I plus 4I is equal to 0. Now it will become minus 10, minus plus 4I plus 4I is equal to 0. And that is 10 divided by 8, 1.25. Answer is 1.25 ampere. Okay, because it is in ohm. It is in ohm, that's why it is in ampere. This is the value of the current. Very, very simple question. The answer for this question is 1.25. 1.25. So any comments if you want to give, guys? Which type of question? What about the level of question in GATE examination? Just for your confidence, we are solving the question so that you will get the idea from the previous year question paper, and we can expect some questions, or we can anticipate some question for what GATE 2024. What will be the level? Okay. Then next one, RA and RB are the input resistance. This is the RA, that is the RB. As shown below, the circuit extends infinitely in the direction shown. Which one of the following statement is true? Here, tell me, these two diagrams are same. It is extended up to infinite, extended up to infinite. So what is the relation between RA and RB? RA is equal to RB, RA is equal to RB is equal to 0, RA less than RB, or RA is equal to. Now, watch this diagram carefully, both the diagrams. Here we are having one extra resistor, 1 ohm. Otherwise, everything is same, 2, 1, 2, 1, 2, 1. What we can do, up to this point, that complete network can be replaced by what RA? Because this is the 2, 1, 2, 1, 2, 1 up to infinite. What is the input resistance up to this point? RA. So what is the RB? 1 parallel with RA. Because 1 and the complete network is replaced by RA. 1 parallel with RA is nothing but value of RB. What is the RB? 1 parallel with RA. 1 into RA upon 1 plus RA. That is nothing but RA upon 1 plus RA. That is the relation between RB and what? RA. So simple. Now watch the network. This point is what? A and B. This is B. Complete network is replaced by RA. This answer is the correct. D is the correct answer for this question. Next one. This one. Now, again, questions from the basics. Then watch this. In the portion of the circuit shown, if the heat generated in the 5 ohm resistance is 10 calorie, this is the 5 ohm resistor, 10 calorie per second, then the heat generated by the 4 ohm resistance in calorie per second is, what is the heat generated across the 4, right? That is asked. No need to convert the calorie into joules and so on, but simple we are going to apply the concept here. Guys, first of all watch, this is these two network are connected in parallel, 6 and 4, 10 ohm, and this is the 5 ohm. And remember, current is inversely proportional to R. More will be the resistance, less will be the current. So here, if you are assuming that, let this is I, right, then it will become I by 2. Or if suppose you are assuming here it is I, then here it will become what? 2I. Because resistance half, current double. Suppose you are assuming I here, then what is the current here? 2I. Because resistor double, current half. So this is the case, resistor half, current double. I, 2I, because these are connected in parallel. Now, no need to convert it into calorie to joule. What is given? 5 ohm resistor is 10 calorie per second. Now, per second means what? It is power. So what is the power? 2I square, because it is the current is 2I, 2I square into 5. Like this is given in what? 10 calorie per second. Okay. Then what is asked? Then the heat generated by the 4 ohm resistance per second. So you can write what is the heat generated per second? I square, because the current is what? I square into 4. You have to find. So 10 divided by P, equation number 1, equation number 2. You can divide 2 divided by 1. So it will become P by 10, because it is P. We have no idea about that. P upon 10. I square cancel out. This is the 4 into 5, 20 divided by 4. And what is the 20 divided by 4? 5. What will be the value of P? You can find the 50 watt, right? 50 calorie. Is it right? Okay. Check my calculation. So I think now it is clear how we can find the value. Because there is a square of the current, then no, calculation mistake. So I will write on the next page. This is 2I, this is I, right? Now, what is the P1? That is given as 10 calorie. 2I square into 5. Then it will become 4I square into 5. That is become 20 times of I square, that is equal to 10. Okay. That this is the first equation. Second, P2. Now you have to find the P2. What is the current I? So that will become I square into 4. Now P2 divided by P1 is equal to, P2 divided by P1 is equal to I square 4 divided by 20 I square. Now it is correct. This I square cancel. What is the P2 is equal to 4 by 20 into P1. 4 by 20 into what is the P1 here? 10 given. 2 calorie per second. No need to change it in joule and so on, because we are using the same unit. We can find a value, right? So that is a very, very simple one. That is the value. 2 is the answer. So in exam, sometimes what we are doing, there may be the chance of what? Silly mistake. Please try to avoid silly mistake. And we will take session on what that effective use what scribble pad, how we can use it effectively, right? वो भी limited page है ना, तो उसका कैसे use करना है और कैसे हम calculation mistakes को remove कर सकते हैं, we have to check here. So this is the 2, what is the answer for the 2 calorie per second is the answer. Now next one. In the given circuit, the current supplied by the battery in ampere is, what is the current supplied by the battery? Which battery? This one, I1. This is I2, that is I2. What is the current supplied by the I1? This is a very simple question, 1 mark question. Now watch this. Apply the KCL at this point. What is the incoming current? I1. What is the outgoing current? I2 and I2, so 2I2. So what is the relation between I1 and I2? I1 is equal to 2I2. So what is the I2 is equal to I1 by 2. Now this is the equation number 1. Now write down the KVL from this point to this point in this loop, because we can't write the KVL through the current source. So this is the -1 plus 1 plus I1 plus 2 times of I2 is equal to 0. I1, and what is the I1 by 2? I2 is I1 by 2. 2 into I1 by 2 is equal to what? 1. And this is 2 cancel. 2I2, 2I1 is equal to 1. So what is the I1 is equal to 1 by 2. That is nothing but 0.5 ampere. So what is the current given by this battery? 0.5 ampere. अब देख लो भाई, क्वेश्चन लेवल ऑन डिपेंडेंट सोर्स, बट वेरी 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 इजी क्वेश्चन. तो अब ऐसे में बस एक ही चांस है सिली मिस्टेक्स होने के, यस और नो. अरे जरा आप कमेंट्स में जरूर कुछ लिखिएगा. तो देखो यहाँ पर चांस है कि आपने कुछ मिस्टेक कर दी या सिली मिस्टेक हो गई, तो फिर आंसर फिर गलत आ जाएगा. ओके, प्लीज ट्राई टू अवॉइड दोस सिली मिस्टेक्स. द नेक्स्ट वन, नेक्स्ट क्वेश्चन इज दिस वन. Yes. Now in the circuit shown below, the node voltage VA. देखिए again 2016 2 mark question, right? 2016 2 mark question. Then node voltage VA. What is the node voltage at this point? Now I1 is given and 10 I1 is the dependent source that depends upon the I1. We can find the node voltage. And you can get the I1 in terms of what? VA also. So how we can solve this question? Then watch this. This is VA. VA minus 10 divided by 10. 5 plus 5, 10. It is the value of I1. What is the I1 is equal to? Let this voltage is VA, node voltage, minus 10. Divided by 10. 5 plus 5, 10. This is the value of I1. Okay. Now you can write the KCL. VA minus 5. This is the incoming current. Now 5 ampere is the incoming current. So you can write the, what is the incoming current? 5. What are the outgoing current? VA minus 0 by 5. Plus VA minus minus plus 10. It will become plus because it is a minus polarity. 10 times of I1 divided by 5. Plus, what is the outgoing current? Already we have calculated. That's why directly you can write what is the outgoing current. I1 is equal to 0. It will save your calculation. Now this is, sorry, this is already equal to what? 5. Now no need to write the 0 because it is 5. You can take 5 as a LCM. VA plus VA plus 10 times of I1 plus 5 times of I1. 25 is equal to 2VA plus 15 times of I1. You will get this equation. This is the equation number 2. Now put the equation number 1 in equation number 2. When I am putting the equation number 1 in equation number 2, here 25 is equal to 2VA plus 15 times of VA minus 10 upon 10. Upon 10. Then you will get 25 is equal to 2VA plus 15 divided by 10, 1.5 VA, right? And that is the 15. That is what? 15, right? Then 15 plus 20, 25 plus 15, 40, and this is the 3.5. So VA is equal to 40 divided by 3.5. 40 divided by 3.5. Check my calculation and everyone give me the answer in comments box. What is the answer for this question? Yes, please. Tell me what is the answer for this one. That is the basic. Please watch the nature of question. Very, very basic question. Okay. You will get around 11.42. Are you getting this answer? 11.42. Okay then. Next question. Another question from the basics of the network. Basic means what? KCL, KVL, mesh analysis, nodal analysis, supernodal analysis, right? And just to find the charge or current and so on. In the circuit shown below, the voltage and current sources are ideal. This is the ideal voltage source, this is the ideal current source. The voltage across the current source is. Now, this 5 ampere, because it is open circuit, the 5 ampere will flow like this. You have to find the voltage across the current source. 0 volt, 5 volt, 10 volt, 20 volt. So very quickly you can solve. 5 ampere means what? This is 5. 5 into 2, it is what? 10 volt. Because this current will pass through this. 5 into 2, 10. Now you can apply the KVL here. V out is equal to 10 plus 10. What is the 10 plus 10? 20. V out is equal to 10 plus 10. That is equal to what? 20 volt. Answer for this question is D. 20 volt. One mark question. Quickly you can solve this. Then next question. This is a good question. In electrical, 1 mark question, but only. You have to apply the concept here. Sai Krishna, that is not mentioned in the syllabus. That is not mentioned in the syllabus, but sometimes what? From the basics of the network, they can ask some questions related to what equations, how many KCL or KVL we can apply, this type of questions. What is the relation between the cord, link, tree, twigs, and so on. Voltage V and current A across a load are as follows. Watch this carefully. 100 sin omega t. This is the voltage. And what is the current here? 10 sin omega t minus 60. 2 sin 3 omega t. That frequency is different. Frequency is different. And then we are having the 5 sin 5 omega t. 5 sin 5 omega t. Now, the average power consumed by the load in what? Average power. This is only 1 mark question. Then it is a tricky question. Now, how we are going to find the average power? So what we are doing, we are finding the instantaneous power. And then we are integrating it. And we are getting the average power from that. Instantaneous power means PT is equal to Vt into It. V2 into It. Now you can multiply the 100 sin omega t with this signal. And then find the values and so on. And apply the formula for sin A, sin B. So sin of omega t. Right? That is multiplied with what? This complete signal. I am not going to multiply it, just I am giving you the trick. Minus 60, then plus 2 sin of 2 omega t plus 5 sin of 5 omega t. That is the 3 omega t. Now, first of all multiply it and then apply the formula of what? Sin A, sin B. Sin A, sin B. 2 sin A, sin B. What is the formula for that? And you can apply here. Right? अजय दीप, आरोग्य दीप, वही नॉर्मल क्वेश्चन है ये. पावर फैक्टर, पावर कैलकुलेट. नो डाउट इन इलेक्ट्रॉनिक्स वी आर नॉट गेटिंग दिस टाइप ऑफ क्वेश्चंस, बट फॉर engineering services exam you can get this type of questions. Or this is the basics, not a too but no doubt it is important for what? Electrical branch, right? But if suppose you opt 2 papers, electronics and electrical, then you have to solve this type of questions. Now, so when we are calculating, guys, remember the average power when it is multiplied with this signal, when we are multiplying with this signal and you are going to find the average value, it will be what? 0. Right? Finally, then because the frequency is different, This is the omega t, and that is what 3 omega t and 5 omega t. So only one term is important, this signal and that signal. And what is the phase difference between these two? 60 degree. And current lags behind the voltage, so lagging phase 60 degree. So you can find the power, what is the RMS value of this, what is the RMS value of this, and the phase is 60. So directly you can apply 1 minute. No. Okay. Multiply this two signals only, then VRMS, IRMS into cos theta. What is the phase difference between current and voltage? That is negative. VRMS 100 by root 2, IRMS 10 by root 2, cos 60. That will become 1000. Hundred by root 2, 10 by root 2, and this is the cos 60. This is the power factor. Cos 60 is nothing but 1 by 2. 1000 divided by 4, that is 250 watt. This is the value of the average power. So tricky question, 1 mark question, directly you can find. To watch the frequency carefully. And then if you want to verify it, please multiply it, and remember, if you are getting the sin omega t or cos omega t, so what is the average value of that signal? 0. Cos of 3 omega t, sin of 3 omega t, then the average value will become 0, guys. Okay, please find the value. Then next one, so directly always multiplies, watch the frequency, same frequency, and what is the phase difference? 60. Negative phase difference means current lags behind the voltage. Okay, then the next question. Now again, this is a tricky question in 2016. In the circuit shown below, the supply voltage is 10 sine of 1000 t. What is the omega here? 1000. The omega radian per second of the signal given is 1000. 1000 radian per second. The peak value of the steady state current through the 1 ohm resistor. Where is the 1 ohm resistor? This is the 1 ohm resistor. In ampere, rounded off to 1 decimal places, right? Now if this type of question is given, parallel RLC circuit are connected, right, or series RLC circuit are connected, then first of all always find what? Resonance frequency. So what is the resonance frequency for this portion and that portion? Because if it is in resonance, then LC will act as what? Open circuit. Combination of LC in parallel will act as open circuit in resonance. So what is the resonance frequency? Omega naught 1 by root over L1 C1. Let this is the L1 C1, L2 C2. To put the value very quickly, you can put without calculator. What is the L1? 4 millihenry. 4 into 10 raised to power minus 3 into 250 microfarad. 250 into 10 raised to power minus 6. 250 into 4, that is the 1000. 1000 and minus 3 cancel out, and it will become 1000 radian per second. Resonant frequency for this is what? 1000 radian per second. And what is the resonant frequency for this? Omega naught is equal to 1 by root over L2 C2. What is the L2? 500 into 10 raised to power minus 3 into 2 into 10 raised to power minus 6. Again you will get the 1000 radian per second. And what is the frequency of the given signal? 1000 radian per second. If the 1000 radian per second, remember LC combination will act as open circuit. This will act as open circuit, this will act as open circuit. So we are having resistor. 3 resistors are in series, and that is the signal 415. What is the total resistance? 5. And what is the peak value of the signal? 10. 4 plus 1 5 plus 5 5 10. So what is the current here? 10 divided by 10, 1 ampere. This is the peak value of the current, 1 ampere. Because in question peak value is asked, peak value of the steady state current, that is 1 ampere. numerical answer type question. And what is given here? Rounded off to 1 decimal places to confuse you. Just for confuse, you have to write the 1.0. 1.0 ampere. That is the answer. Okay. So this is the very simple. So in this type of questions, just see what about the resonance. So yesterday I have solved one question. Now question on what? Circuit theorem. So already basics gone. Now the circuit theorem from the electrical branch, guys. तो कैसा लग रहा है आप लोगों को सेशन से? आपको समझ में आ रहा है क्वेश्चंस का लेवल कैसा है? आईआईएससी बैंगलोर प्रीवियस ईयर क्वेश्चन पेपर हम सॉल्व कर रहे हैं 2002, 2008 एंड 2016 नेटवर्क circuit theory. From first of all, I have solved the question from electronics branch in part 1. Now I am solving the question from electrical branch in part 2. Okay, and then watch all the questions. तो कॉन्सेप्ट बेस्ड है, बहुत ही ट्रिकी क्वेश्चन है, बहुत तेजी से आप एग्जाम में से बना सकते हो, बस थोड़ा आपको ध्यान रखना होगा एंड ट्राई टू अवॉइड सिली मिस्टेक्स. सर्किट थ्योरम. Thevenin's equivalent of circuit operating at 5 radian per second has open circuit voltage 3.71 minus 15.9 degree. Z0 is equal to 2.38 minus this is a negative value here. ZTH. Negative means what? Capacitive in nature. At this frequency, the minimal realization of Thevenin's impedance will have. Minimum realization of Thevenin's equivalent. Again, that is a tricky question. Now, here we are having the Thevenin's voltage. Here we are having the ZTH, that is called Z0 or ZTH. This is called VTH or V0, sinusoidal signal. Now this one. Now ZTH is equal to, what is the ZTH? 2.38 minus J 0.667. It is definitely R minus J omega C, or it may possible that it has inductor as well as capacitor, but the capacitive impedance is more. So there are two chances. There are two chances. One resistor and one capacitor, or one resistor, one capacitor and one inductor. Both possible. Because R has the real value positive. So what is the real value? Definitely there is a resistor, 2.38. 2.38. And if you are having the only capacitor, then J 0.667. That is the impedance because of the capacitor. Or what is this? R plus what? J omega L minus J by omega C. That is also the impedance. Now in that case, this capacitive impedance should be greater than what? J omega L. Then this term will become negative. Means XC, magnitude of XC should be greater than magnitude of XL. Right? 1 by omega C should be greater than 1 omega L. Again, but what is the keyword use here? Keyword is the minimal realization. Minimal means what? We have to use the minimum number of components. If you want to use the minimum number of components, means what? Resistor and capacitor. This is also correct. Resistor and capacitor and what? Inductor. But condition is not given or minimum number is given. So resistor, it is not possible. Capacitor, inductor not possible because real part is positive. That's why B is the correct answer for this question. MCQ. It is a MCQ. If it is MSQ, that minimal is not given, A and B both are correct. A and B both are correct. Okay. With condition. Next question. So this is the answer B for this one. Now guys, transient analysis. Transient analysis. So first of all, we'll solve the question on DC transient. So this is the transient analysis. First question. Consider the circuit shown in the figure. If the frequency of the source is 50 Hz, then the value of T0 which result in a transient free response. So it is a DC transient or AC transient. So that now in case of electronics branch, now we are getting question from what? DC transient. But in case of electrical branch, we can get the question from what? AC transient also. So this is the AC transient. This is the AC signal is given sin omega t. Then the value of T naught which result in a transient free response is. So if you want the transient free response, then how we can write? But what is the transient here? You have to get the idea. Then watch this carefully. What is the meaning of the transient here? Then this one. Now, first of all, this is ZL. What is the impedance here? 5 ohm plus j omega L. What is the omega here? 2 pi f. 2 pi into what? 50 hertz. It is nearly equal to 314. Because pi we are taking 3.14, that has become 314 radian per second. 314 radian per second. So when we are writing here j omega into L 0.01, so it will become 3.14. That is the value of ZL ohm. Okay. From this you can find the magnitude of ZL. Root over 5 square plus 3.14 square. Okay, find the magnitude of ZL. Then once the magnitude of ZL is known, what is the steady state solution and what is the transient part? Now remember, then this is given when the switch will be closed. When the switch will be closed, so that we are getting what? Transient part is equal to 0. So then watch this. What is the solution for this one? For this type of question, total solution IT. For example, I am going to find the IT. Steady state current plus what? Transient. Now, what is the steady state current? Remember, steady state current is given by, what is the signal is given? Signal is given as sin omega t upon Z. This will become sin omega t upon Z. When I am writing, and plus what is the transient? Because it is a RL circuit. Because it is a RL circuit. Just I am giving you the RL circuit. Make it what? Short circuit. Make the source 0. Then it will become, write down the equation, IR plus L di by dt is equal to 0. You will get the first order differential equation is equal to 0. So what is the d plus R by L? So what is the d minus R by L? So what is the transient part? To find the transient part, you have to get the homogeneous equation. The homogeneous equation you can write k e raised to power minus R by L into t. That is the transient part. Remember, it is the transient part. So k e raised to power minus R by L into t. Then what is this part? It will become 1 by mod of Z. You have to find the mod of Z from this. This is the mod of Z. Already you have to solve this mod of Z, and then you can find the angle also. You can find the angle of this, that is what? Theta. Tan inverse of 3.14 imaginary part upon what? Real part 5. Because it is an inductive, that is angle is what? No doubt positive, but current lags behind the voltage. Current lags behind the voltage. Then okay, so what is the solution here? 1 by mod of Z, that will become the magnitude of this sine of omega. Already we have 340. This is the 314t minus theta. What is the theta? Already I have given tan inverse of 3.14 divided by 5. Then plus k e raised to power minus r by l, you can find the time constant, and that is the t. Now at which time the t, that switch should be closed, right? So write down the yahan, this is the t naught and that is the k, and the value of the k should be equal to what? You have to get the value of k should be equal to what? 0. So when you want the value of the k should be equal to 0, guys, this term should be equal to 0. This term. And when it will be 0? When this angle is what? 0. So you have to simply equate it. 314 t naught, this is the time at which this angle will become 0, minus theta is equal to 0. So what is the t naught is equal to? Theta upon 314. And remember guys, this theta should be in what? Radian per second. Radian, in radian. When we are getting the radian divided by 314, and then you will get the time, guys. If you have the calculator, then find it is in radian, and this term should be equal to 0, so that we will get the k is equal to 0. Was the k is equal to, because the initial current, what is the current? When the switch will be closed, inductor does not allow sudden change of what? Current. You have to equate this current is equal to 0. Exactly at t equal to t naught, switch closed, inductor does not allow sudden change of current. So what is the initial current? 0, just after the switch closing, and you can equate it. This is the 1 by z sine of 314t minus theta plus k e raised to power minus r by l t naught. Equate it, and from that we want the k should be equal to 0. For k is equal to 0, this angle should be equal to 0. And therefore (14). So please, theta should be in radian, and then you will get 1.78 millisecond. 1.78 मिलीसेकंड. देखो, अगर आपका ये ऑब्जेक्टिव की बजाय एनएटी टाइप क्वेश्चन आ गया और आपने इसको डिग्री में रख दिया थीटा, तो आपको गलत आंसर मिल जाएगा. तो आप पहले रेडियन में अपने मोड को डालिए कैलकुलेटर को, और देन फाइंड द वैल्यू. नेक्स्ट क्वेश्चन. Next one, this is the answer is 1.78. Now, an 11 volt pulse of 10 microsecond duration. This is again a conceptual question. 11 volt pulse, 10 microsecond is the duration, is applied to the circuit shown in the figure. Assuming that the capacitor is completely discharged prior to applying the pulse, the peak value of the capacitor voltage is. What is the peak value of the capacitor voltage? Then what is the duration of the pulse? Only 10 microsecond. So for 10 microsecond, you can find the equation. So what is the final voltage across the capacitor? At t equal to infinite, it will act as open circuit. So as you know, equation across the capacitor is given by V final minus V final minus V initial e raised to power minus t by tau. Tau is the time constant. What is the final voltage? Finally, this capacitor will act as open circuit. At t equal to infinite, this capacitor will act as open circuit. This is 11 volt pulse. So what is the, if suppose you are giving the 11 volt, no doubt it is applicable only for 10 microsecond, but suppose if you are giving the 11 volt, so at t equal to infinite, what will be the voltage? At infinite, it will become 10 divided by 1 plus 10 into 11. So that is the 10 volt final. What is the initial voltage? 0, because it is unenergized circuit. So what is the time constant? Time constant is R equivalent into C. To make the input 0, 1 and 10 kilo ohm are in parallel. So what is the R equivalent across the C? This is called RTH also, across the C. 10 parallel with 1. 10 into 1 upon 10 plus 1. This is the R, this is the value of the R actually. R equivalent. That is the 10 by 11 kilo ohm. What is the time constant? RTH into C, 10 by 11 kilo ohm, and it is nanofarad. Capacitor is 11 nanofarad. 10 into 10 is 9. 11 cancel and you will get the 10 microsecond. 10 microsecond is the time constant. And what is the duration of the pulse? It is also 10 microsecond. So we are getting only one time constant. Only one time constant. So what will happen when we are giving the one time constant? This is the voltage across the capacitor. Right? Capacitor start charging, but at this point when it reached here, in one time constant when it reached here, because what is the voltage applied? 10 volt. Voltage applied is 11 volt, but across the capacitor highest voltage is 10 volt. Then after that it will suddenly drop from 11 towards 0. The capacitor will charge and after that it will start discharging. It will start discharging. So what is the peak value at this point? It is asked. So what is the equation here? V final 10. What is the V final 10? What is the initial 0? E raised to power minus t by tau. What is the tau here? 10 microsecond. Then you will get 10 1 minus e raised to power minus t by 10. This is in microsecond, remember. So exactly at t equal to 10 microsecond, you will get the peak value. 10 1 minus e raised to power minus 1. Put the 10 cancel. And well-known formula, in one time constant capacitor will charge up to what? 63.2% of final value. So it is nothing but 6.32 volt. 6.32 volt is the answer for this question. Pulse over to peak value charge up to 6.32. That is the answer. This answer is C. C is the answer for this one. Now watch this question. The time constant for the given circuit will be, again 2 mark question in 2008 in electrical branch. Right, what will be the time constant? First of all, you can find the C equivalent, 1 farad in parallel and 1 farad in series. 1 1 2, 2 into 1, because first of all find the C equivalent. 2 and 1 are in series. 2 into 1 upon 2 plus 1. That is the 2 by 3 farad in capacitor. This is the capacitance equivalent, 2 by 3 farad. And here we are having the battery. This is the current source. Okay. Now remove the capacitor and find the RTH across that so that you can find the time constant. RTH into C. So remove this capacitor. So when we are removing this capacitor and just to find the RTH, remove this capacitor. Current source will act as open circuit. So what about the resistance? At this point, current will act as open circuit. Then what is the RTH? RTH is nothing but 3 plus 3 into 6. So what is the time constant? RTH into 6, 2 by 3, 4 seconds. Because 2 by 3 is the C equivalent. So this is the 4 seconds. Okay. Within 20 seconds you can solve this type of questions. So R equivalent, C equivalent, and then you can find the value of the time constant for this particular circuit, guys. Then next one, that is given. This is called linked question. Statement for linked answer question. The current IT is sketched in the figure flows through an initially uncharged 0.3 nanofarad capacitor. This is given, it is visible to you. First of all, it will increase from 0 to 4. Then it is decrease from 4 towards 0 from this duration. From 2 to what? 8. This duration is 6 and this duration is 2. Means in 2 step it will increase by 4 and in next 6 state it will decrease by what? 8. So guys, you can also find the slope. 4 by 2 is the slope of this portion. 4 divided by 2, the change in the time, and this is the change in what? Value. So 4 by 2. So in one step it will increase by the 2. Similarly, when it will decrease from 4 to 0, So this is what 1 step, 2, 3, 4, 5, 6. So what is the slope of this line? 4 divided by 6. 4 divided by 6, that is the 2 by 3. So in one step it will decrease by the 2 by 3. In one step it will decrease by the 2 by 3. That is the slope of this line. This slope is negative. This slope is positive. But what is asked? The current sketched in the figure flows through an initially uncharged 0.3 nanofarad capacitor. It is a linked question. Charge stored in the capacitor at 5 microsecond will be. So if you want to find the charge, guys, charge is nothing but integration of I dt. Or integration means what? Area. So up to 5 microsecond you have to find the area. This area you have to find. This area you have to find. This area. This is the required area. So very, very easy method to find the area is, this is A1 is required, A2. Let the total area is A. A minus A2 will give you the A1. A minus A2 will give you the A1 because it is very easy to find the area of the triangle. Right? Now, because the, watch this, 2, 3, 4, 5. What is the step size? 1, 2, 3, 4, 5 and 6. Already I have given the slope of this line minus 4 by 3. 4 by 6, that is minus 2 by 3. So if in one step it will reduce by 2 by 3. So in 2 step 4 by 3. In 3 step it will reduce by what? Minus 2 by 3 into what? 3 steps. This value is what? 2. How we can say 2? Because in one step it will reduce by 2 by 3, again 2 by 3, again 2 by 3. So exactly at 5 it will be what? 4 minus 2, that is what? 2. Value at this point is 4 minus 2, that is what? 2. You have the height, so you can find the A2. A2 is equal to half of base 3, height 2, that is the 3. And what is the total area? Half of base, what is the base from this point to this point? 8 into height. What is the height? 4. Then it will become 16. So what is the required one? 16 minus 3, that is the 13 nanocoulomb. 13 nano. Why nanocoulomb? Because it is in microsecond, current is in milliampere. So what is the multiplication of milli and micro? Milli means 10 to the power 3, 10 to the power minus 6. That is nothing but 10 to the power minus 9. That's why the charge will be in nanocoulomb. This is the answer, 13 nanocoulomb. Very, very simple one. Then next question, linked question. This is a linked question. What is asked here? Capacitor charge up to 5 microsecond. Means we are providing the current through the capacitor up to 5 microsecond. Up to 5 microsecond already we have calculated the charge. What is the charge up to 5 microsecond? Already we have calculated 13 nanocoulomb. Now it is connected across an inductor of 0.6 millihenry. Then the value of the voltage across the capacitor after 1 microsecond will approximately be. Now the capacitor is charged and it is connected across an inductor of 0.6 millihenry. This is C, this is L. Right? Then value of the voltage across the capacitor after 1 microsecond. And what is the value of the capacitor? In the first link part it is given. Value of the capacitor is 0.3 nanofarad. 0.3 nanofarad. And what is the value of the inductor? 0.6 millihenry. Millihenry. Now it is just like a tank circuit. Then already it is charged by what? 13 nanocoulomb. So this is the initial. You can find the initial voltage across the capacitor. What is the voltage across the capacitor? Q initial upon C. 13 into 10 raised to power minus 9 upon 0.3 into 10 raised to power minus 9. Because it is nanofarad, cancel. 13 by 130 by 3 volt. This is the initial voltage across the capacitor. Now it is a LC circuit only. So what will be the solution LC circuit? Transient, I will give the idea about the transient. No. Because there is no R. Because there is no R. So what is the alpha? Alpha is equal to 0. What is the omega naught? Omega naught is equal to 1 by root over LC. Put the value of L and C and you can find the omega naught. Then what will be the general solution? It is a undamped response because there is no resistor. So what is the voltage across the capacitor for one undamped response? It is given by K1 cos of omega naught t plus K2 sin of omega naught t. That is the solution. That is the solution for this question. Now, K1 cos of omega naught to K2 sin of omega naught t. What is asked here? What is the value at 1 microsecond? What is the value at 1 microsecond? Find the omega naught first of all. 1 by root over LC. Then how we can find the value of K1 and K2? Remember, capacitor does not allow sudden change of voltage and inductor does not allow sudden change of current. So what is the initial voltage across the capacitor? 130 divided by 3. So exactly at t equal to 0, what is the value of the K1? So Vc is what? 130 divided by 3. K1, cos of 0 is 1, cos sin of 0 is 0. So you can find the value of K1. Right? So you can find the value of K1. What is the initial current through the inductor? 0. And that current will pass through the capacitor also because they are connected. So this is the one. What is the current through the capacitor? C dVc by dt. C dVc by dt. So what is the dVc by dt? 0 plus. Because inductor does not allow sudden change of current. It is initially 0. That's why this is also 0. dVc by dt is what? 0. Exactly at t equal to 0. So first of all, differentiate this equation. dVc by dt is equal to K1 omega naught sin of omega naught t plus K2 omega naught cos of omega naught t. Now put at t equal to 0, dVc by dt is equal to 0. What is this? 0. Sin omega naught t will become 0 plus K2 omega naught because cos omega t is 1. What is the K2 from that? 0. K2 is equal to 0. So what is the solution? Now next time remember this. Once the capacitor is charged, inductor is not charged, then answer is what? K1 cos of omega t. And what is the value of the K1? 130 by 3. Once you will get the Vc is equal to 130 by 3 cos of omega naught t. My dear friend, put the value of 1 microsecond and get the value of omega naught also. 133 divided by 3 cos of omega naught means 1 by root over LC. And t 1 microsecond means 10 to the power minus 6. Multiply it, get the value. And you will get the answer here. You will get the answer here negative. Right? Minus 30.6. Please check my calculation. Minus 30.6. So what is this? Undamped response. Undamped means there is no R. Undamped oscillation. You are getting the K1 cos of omega t and find the value of K1 and then you can find the value. Put the value of t 1 microsecond. But remember in your calculator guys, degree to radian or radian to degree. That is very important. Otherwise you will make what? Silly mistakes. Right? When you are multiplying with the omega, you will get the answer in radian. But if your calculator is in what? Degree mode, it will not work. You are going to get the wrong answer. First of all, change the mode from degree to radian, or you can convert the radian into a degree by multiplying it with 57.3. 57.3 and then you will get this answer. Okay then. Next one. Already I have solved this question. Now, in the circuit shown below, the initial capacitor voltage is 4 volt. Switch S1 is closed at t equal to 0. The charge lost by the capacitor from t 25 microsecond to t 100 microsecond is 25 microsecond to 100 microsecond. What is the charge lost? it is asked in this capacitor and resistor. It is a source free response. Initial capacitor voltage is 4 volt. Switch S1 is closed. The charge, okay. Now what is the time constant of this circuit? Once it is closed, remember in a source free response, final voltage is 0. So what is the voltage across the capacitor? V final minus V initial e raised to power minus t by tau. So what is the final voltage? 0. What is the final voltage? 0, because it is a source free. What is the initial voltage? 4 minus t by tau. It will become 4 e raised to power minus t by tau. What is the tau here? 5 into 5, that is 25 microsecond, because it is in microsecond. So it will become 4 e raised to power minus t by 25 microsecond. Okay. Then it is exponentially decreasing function. We have the standard formula for this. Directly you can give. Quickly in exam you have to apply the concept here. This is the case. In one time constant it is reduced by what? 36%. Or in 4 time constant it is reduced up to 98%. That is the standard value. 36.2, right, of initial value. Percent of initial value mean 0.362 of initial value, that is the 4 volt. And here 0.02 of the initial value, 4 volt. Why I am calculating? Because it is a 25 microsecond. And that is nothing but time constant. And what is given? Question 100 microsecond. 25 microsecond and 100 microsecond. So what is the voltage at this point? 0.362 into 4, 0.02. So what is the change in the voltage? You can find what is the change in the charge. Change in the charge is given by C, change in the voltage. Now what is the value of the C? C is here 5 microfarad. 5 into 10 raised to power minus 6. What is the change in the voltage? 4 is common. 0.362 minus 0.02 into what? 4. That is the change in the voltage. Multiply it and you will get the what is the change in the charge. Change in the charge. So here we are calculating the value in what is in 25 microsecond. What will be the value in 100 microsecond? What will be the value? But what is the 25? 25 is tau. And what is the 100? 100 is 4 tau. Right. Means in one time constant it will reduce by 36% or 37, nearly equal to 36.8. Sorry, this is 368. This is the not 362, 368. 0.368. Make it what? 0.368. Yes. So in one time constant it will reduce by what? 36.8%. Or in 4 time constant it will reduce by what? 98%. Directly from the graph. No need to calculate it. Okay, so you can solve like this. So now my dear friend, time is over. I am giving you some homework. Before giving, guys, this Sunday means on 3rd of September, you have golden opportunity to give what? Test. That is a scholarship test and you can start your journey with us. Okay, अरे एक opportunity है and get up to 90% off on our program and window will be open from 9 AM to 9 PM means total 12 hours. कभी भी आपको जब भी टाइम मिले आप टेस्ट दे दीजिए, रजिस्टर कीजिए अभी और स्टार्ट कीजिए अपनी प्रिपरेशन. वी आर गोइंग टू स्टार्ट व्हाट? क्रैश कोर्स फॉर गेट 2024. फुल प्रूफ प्लान है और आप गेट में टॉप रैंक ला सकते हैं. अभी भी आपके पास पूरे 5 महीने. कैसे लाना है? नाउ आई एम गोइंग टू टेक वर्कशॉप फॉर यू. रोड मैप टू बी अ गेट टॉपर इन जस्ट 5 months. टुमारो 7:30 PM 29th of August. I will share my experience. I will give you idea how to make proper revision plan and how to cover the syllabus within 5 months and how to avoid the silly mistakes during exam. Each and everything we will discuss and you can also ask your questions. Okay, so that is my profile, guys, and I am having 22 years of teaching experience. I will share my experience with you. Okay, so please join that workshop. Register now for this. Then, and we have some more questions on steady state analysis of sinusoidal signal and guys 2-port network, and some questions on what network function, and 1 or 2 questions from what balanced 3-phase circuit, guys. So if you want the PDF of this session, so you can join my Telegram channel, and then 1 minute. And these are the course: GATE EC full course, complete syllabus coverage; GATE electronics crash course, complete revision in last 4 months, guys. So these are the faculty members, and that is the GATE electrical crash course. बहुत जल्द start हो रहा है, where we will provide you live classes, recorded lecture, practice session, practice quizzes, mock test. For more detail you can call at this number. Okay, और आपको डिस्क्रिप्शन बॉक्स में भी मिल जाएगा, वहां से भी आप नंबर ले लीजिए, कॉल कीजिए, स्कॉलरशिप टेस्ट दीजिए, राइट। और इस पीडीएफ के लिए आप मेरा सेशन ज्वाइन कर सकते हैं, ज्वाइन माय टेलीग्राम ग्रुप। ओके गाइज, so that is electronics by Sanjay Rathi. Thank you very much for attending the session. You are on BYJU'S exam prep. Like the session, share the link of this session, okay, and subscribe our channel. Thank you.